Damas y caballeros, la Universidad de Guadalajara expresa el atento saludo a todos ustedes para la inauguración de la sexta edición del Ifses Forum 2018. Me honro en presentar a ustedes a la académica e investigadora de la Universidad de Calgary, doctora Jennifer He, el presidente del Ifses Forum 2018, el ciudadano Ernesto Cervantes Llamas, el presidente de la Federación de Estudiantes Universitarios, el compañero Jesús Arturo Medina Varela, la rectora del Centro Universitario de Ciencias Exactas e Ingenierías, doctora Ruth Padilla Muñoz, y presidiendo el evento la doctora Carmen Enedina Rodríguez Armenta, con la representación del doctor Miguel Ángel Navarro, rector general de la Universidad de Guadalajara, vicerrectora ejecutiva. A continuación, escucharemos las palabras del presidente del Ifses Forum 2018, Ernesto Cervantes Llamas. Adelante.
Muy buenos días tengan todos ustedes. Distinguidos miembros del Presidium, agradezco su presencia en esta ceremonia inaugural. A nombre del Consejo Internacional del Ifses Forum, del Comité Organizador de Ifses 2018 y el equipo, quienes conformamos este gran proyecto, les doy la más cordial bienvenida a esta sexta edición del Ifses Forum. Este foro, que ha sido abrazado por nuestra alma mater, en la cual hemos aprendido la importancia de nuestras ideas, pero no solo el concebirlas, sino ponerlas al servicio de nuestra sociedad, esperando lograr el beneficio común. Vaya, hemos aprendido, piensa y trabaja. He ahí la razón del mismo. Este espacio en el que convergemos estudiantes, académicos e investigadores de distintas líneas de acción, pero reunidos por un interés común, la búsqueda de soluciones a los problemas que aquejan a nuestra sociedad desde un enfoque científico. Sin duda alguna, en estos tiempos difíciles, en donde el mundo se encuentra sumergido en una marea de violencia, de discursos de intolerancia y muros que se oponen al libre flujo de ideas, optar por vías que promuevan el desarrollo académico, científico, tecnológico y cultural es la mejor forma de demostrar que queremos un mundo en el cual las sociedades convivan de manera armónica y que la competencia real sea por quién hará el siguiente gran descubrimiento. Han pasado 6 años desde que un grupo de jóvenes entusiastas, impetuosos por crear un espacio donde convergieran las ideas, proyectos y aspiraciones de estudiantes de distintas instituciones, sentaron las bases para la creación de este foro. Un espacio que ha fungido como plataforma para el desarrollo de las relaciones tanto académicas como interpersonales, las cuales son fundamentales para la realización de cada individuo. Bienvenidos a Ifses Forum 2018. Enhorabuena y que sea de provecho para todos.
A continuación, el presidente de la Federación de Estudiantes Universitarios, con su mensaje, el compañero Jesús Arturo Medina Varela.
Bueno, muy buenos días a toda la comunidad de ingenierías que nos acompañan el día de hoy. Me siento muy honrado de poder estar aquí y mucho más honrado de sentarme con tan talentosas mujeres de nuestra Universidad de Guadalajara y con tan honrosa invitada también que va a dar la primera charla el día de hoy, que tuve la oportunidad de conversar con ella hace un momento. Me parece que es muy relevante este proyecto porque Ifses primero tiene una distinción sobre muchos eventos. Este evento es organizado específicamente por la comunidad estudiantil. Eso le da una característica muy interesante a este proyecto porque no fue una idea que surgió un año o dos, sino ha sido tan consistente que esta es su sexta edición, pero además cumple con una de las muy importantes misiones que tiene nuestra universidad, que es la internacionalización. ¿Qué buscamos aquí? Bueno, pues generar a través de experiencias internacionales la oportunidad de colaborar, de compartir ideas, experiencias, pero también cumple con la expectativa de la circulación de cerebros, que es algo que hemos estado tratando de empujar de manera constante en la universidad y ya es algo que se está haciendo por estudiantes. Yo he tenido la posibilidad de conversar con algunos de los organizadores de Ifses y hicimos un planteamiento que me voy a atrever a adelantarlo un poco, que en el 2019 tenemos una idea de cómo este proyecto puede llegar a consolidarse aún más en el occidente del país y bueno, vamos a promover que el modelo que tiene Ifses lo vamos a replicar en Lagos de Moreno y vamos a convocar a estudiantes de Aguascalientes, vamos a convocar a estudiantes de Guanajuato, vamos a convocar a estudiantes de la región del occidente de Colima, de las ingenierías aquí en Guadalajara y bueno, las que también se dan en el resto de Jalisco para reunirnos en Lagos de Moreno y hacer un motor muy importante por el lugar específicamente donde está, para que este proyecto que se llama Ifses, bueno, pueda detonar también en las regiones del estado de Jalisco. Entonces estamos pensando en llevarlos a las regiones y va a ser muy interesante lo que se va a poder hacer en este lugar. Déjenme decirles que en los próximos días también nosotros tenemos muy claro que proyectos como Ifses, que a través del conocimiento científico buscan solucionar problemas, también creemos en que el conocimiento empírico puede hacerlo a través de compartir experiencias. Por eso el CUCEI va a ser sede de un evento importante de colaboración con un formato de camping nocturno donde se van a compartir experiencias con otros jóvenes que están innovando allá afuera y que ya están poniendo los conocimientos para resolver problemáticas específicas. Y bueno, esto va a ser muy importante porque lo queremos hacer con estudiantes de ingeniería, colaborando con otras áreas específicas del conocimiento. A mí me da mucho orgullo esto que se está haciendo aquí, me da mucho orgullo que sea un evento empujado por estudiantes, me da mucho orgullo que estemos logrando compartir experiencias internacionales y que las pongamos en práctica en esta bella ciudad, en esta Universidad de Guadalajara. Y bueno, el mejor de los éxitos a los organizadores de Ifses y no tengo nada más que decirles que muchísimo éxito en esta gran jornada. Cuentan con todo el apoyo de la FEU. Gracias.
Acto continuo, la rectora del Centro Universitario de Ciencias Exactas e Ingenierías, doctora Ruth Padilla Muñoz, también con su mensaje.
Muy buenos días. Tengan todos ustedes. Quiero agradecer de manera particular y especial la presencia de la señora vicerrectora ejecutiva de esta casa de estudios, la doctora Carmen Rodríguez Armenta, quien es precisamente egresada del Centro Universitario de Ciencias Exactas e Ingenierías. Nos da mucho orgullo tenerla en este presidium y en la posición en que se encuentra actualmente, doctora. Por supuesto, a Jesús Medina, a nuestros compañeros estudiantes que han organizado esta actividad y a la doctora que hoy nos da la conferencia inaugural, así como a todos los estudiantes, profesores que no solamente provienen del Centro Universitario de Ciencias Exactas e Ingenierías, sino de otras entidades de la República y de nuestro estado, otros centros universitarios, así como visitantes de otros países. Tal como lo decía Jesús Medina, es un orgullo para el centro universitario que sean los jóvenes ingenieros e ingenieras quienes estén impulsando actividades de esta naturaleza, en donde no solamente se interrelacionan con sus partners, donde encuentran vínculos para el desarrollo académico, sino para el futuro desarrollo profesional, e involucran a un tópico que para la institución es fundamental, la investigación. Y esta investigación la están vinculando entre los estudiantes de pregrado y los estudiantes de posgrado con investigadores consolidados. Son oportunidades de desarrollo que la universidad quiere promover, pero que en este caso es el estudiante el que asume la responsabilidad del compromiso de formarse más allá de las aulas en una relación internacional con otros estudiantes, otros investigadores, otras universidades y áreas de conocimiento que les son afines. De esta manera, esta promoción de aprendizajes por deseo propio, por compromiso propio, cumple con un aspecto fundamental de los perfiles de la Universidad de Guadalajara, que es aprender para toda la vida, y ustedes están haciendo lo necesario para que tomen en el futuro iniciativas en que esta expectativa se cumpla, pero también porque el hecho de que los estudiantes de ingenierías asuman compromisos tales como la organización de un foro de estas dimensiones, de esta naturaleza, evidentemente les forma también en lo que hoy se llaman competencias transversales o competencias genéricas, esa capacidad para conformar equipos, para colaborar, para innovar, para impulsar proyectos conjuntos que evidentemente van a llevar a plantear soluciones a problemas ingentes en el área de las ingenierías, desde el tema del agua, el aire, las nuevas tecnologías. Por esa razón nos sentimos muy orgullosos de estar el día de hoy aquí, pero especialmente en este maravilloso recinto que es el Paraninfo de la Universidad de Guadalajara, el corazón donde late la inteligencia de nuestra institución, pero también el amor, la pasión, el esfuerzo y el compromiso con el pueblo de México, ilustrado en los murales de Orozco. Muchísimas felicidades a todos quienes han hecho posible este trabajo. El CUCEI solamente ha sido como la malla de contención para abrazar un proyecto como el de ustedes, que crezca, que se solidifique y que avance en el tiempo en beneficio de ustedes y de muchos otros. Muy bienvenidos todos a la Universidad de Guadalajara y que tengan un exitosísimo foro. Excelente día.
Enseguida, la vicerrectora ejecutiva, doctora Carmen Rodríguez Armenta, en representación del rector general de la Universidad de Guadalajara, doctor Miguel Ángel Navarro Navarro.
Muy buenos días a todas y a todos. En nombre del rector general de la Universidad de Guadalajara, nos da muchísimo gusto que hayan elegido el Paraninfo Enrique Díaz de León, este lugar este recinto donde se toman las decisiones más importantes para nuestra casa de estudios para desarrollar este 6º Foro de Ciencia e Ingeniería Ifses 2018. Doctora de mi centro universitario de origen, la doctora Ruth Padilla Muñoz, muchas gracias. Me da mucho gusto que el verde sea nuestro color el día de hoy. Eso está muy bien. Presidente de los estudiantes, qué bueno que estás aquí impulsando a tus compañeros. Y bueno, por supuesto, deseo felicitar a Ernesto y a todo el equipo de trabajo para que entre ustedes puedan generar condiciones de aprendizaje permanente. Welcome, Dr. Xi. Muchas gracias. Bienvenida a nuestra Universidad de Guadalajara. Y bueno, alguna vez fui estudiante como ustedes y ahorita que estaba viendo sus rostros de inquietud y de expectativa, recordé cómo hace ya bastantes años alguna vez organizaba foros en mi escuela, en la Facultad de Ingeniería, y esta posibilidad que ustedes tienen de poderlo hacer internacional, la verdad es que es algo que hace 30 años no podíamos. Es decir, tienen ahora ustedes todas unas grandes, poderosas herramientas en los temas de tecnologías para poder convivir entre ustedes, para poder compartir el conocimiento. Y bueno, anteriormente no se obligaba el tema del inglés. Sus profesores podrían constatarlo, no era obligatorio para los estudiantes, ahora sí. ¿Sí? Ustedes requieren salir siendo ingenieros con una visión global de la problemática que vivimos, con un manejo del idioma importante para poder seguir compartiendo los conocimientos y seguir aprendiendo permanentemente. Pero sobre todo con esta capacidad de poder entre ustedes colaborar y aprender. Vivimos en la sociedad de la información y el conocimiento, y eso nos obliga a los que somos profesionistas en el área de ingeniería a estar permanentemente actualizados, a no depender de las tecnologías de otros países, sino a crearla, a desarrollarla. Aquí tenemos mucho talento y no podemos nada más dejar que las nuevas tecnologías de otros lados vengan y nos digan hacia dónde apunta. ¿Qué tal si dentro de ustedes o de aquí, dentro de esta sala, alguno de ustedes puede ser el nuevo Mark Zuckerberg, ¿no? ¿O han pensado que ustedes pueden ser el Steve Jobs que nos hace falta para los nuevos, para las nuevas creaciones de tecnología? A lo mejor sí. A lo mejor dentro de ustedes y junto con sus compañeros pueden generar estos nuevos líderes que necesita el mundo para cambiarlo, sin olvidar el humanismo y la necesaria colaboración y el cuidado de nuestro planeta. Así que celebro que estén aquí, que hayan organizado este importante foro y que la Universidad de Guadalajara seamos sede del mismo. Así que sin más, les voy a pedir que se pongan de pie, por favor, para la inauguración formal. Y en nombre del rector general de la Universidad de Guadalajara, siendo las 9:40 del día lunes 23 de abril del 2018, declaro formalmente inaugurados los trabajos del sexto Foro Internacional de Ciencias e Ingenierías Ifses, Foro 2018, que el trabajo sea de provecho. Mucho éxito y bienvenidos nuevamente a la universidad. Gracias.
Los invitamos a tomar sus lugares. Muchas gracias a los integrantes del Presidium. Los invitamos también para tomar sus lugares en la primera fila. Permanecen en el Presidium el compañero Ernesto Cervantes Llamas, presidente del Ifses, Forum 2018, y también la doctora Jennifer G., quien será la expositora magistral en unos instantes más. Bien, para dar inicio a lo que será esta exposición magistral, vamos a ceder nuevamente el uso de la palabra al compañero Ernesto Cervantes Llamas, quien hará la presentación curricular de nuestra invitada. Adelante, por favor.
La doctora Jennifer G. es una destacada investigadora y profesora adscrita al Departamento de Ingeniería Civil de la Facultad de Ingeniería de Schulich de la Universidad de Calgary, en Canadá. Realizó sus estudios de licenciatura en la Universidad de Wuhan, China, su maestría en la Universidad de Kioto, Japón, y el doctorado en la Universidad de Calgary, Canadá. La doctora G. se ha especializado en la hidráulica e hidrología. Cuenta con 7 reconocimientos locales, 29 publicaciones de alto impacto y 4 publicaciones en libros y revistas. Nos acompaña en esta ocasión con su conferencia magistral Urban Stormwater Management and Hydraulic Modeling.
Okay, so I need to speak to here. Okay, I know. Okay. Maybe that's better to do this way. Okay, good morning, everyone. So, here, or I hope. hold it, right? I hold it then. Okay, thank you. Sorry, I apologize. So good morning, everyone. So firstly, I would like to take this opportunity to thank you, the organization committee, to give me such a wonderful opportunity to share my research in the urban stormwater management hydrological modeling. So firstly, I would like to ask you a question. How many of you heard about the University of Calgary? Please raise your hand. I know you don't need to raise your hand. Okay, so not that many, because our university, of course, compared to the University of Guadalajara, is pretty young. Okay, so first I would like to give you a short introduction about our university. So the University of Calgary is located in the city of Calgary, the province of Alberta of Canada. So hopefully you can see, I do not know if the laser point works or not, so use mine. So as you can see, okay, I cannot see anything there on the screen. Okay, so the province of Alberta is one of the western province in Canada. So the province is very famous for the oil and the gas industry, and the Alberta beef is very famous as well. I think you know the Alberta beef. So if you look at the Alberta, the province, so the capital city of the Alberta, that is Edmonton. The city of Calgary is located in the south, further south of the Edmonton. So our campus, the University of Calgary, is situated in the northwest quadrant of the city of Calgary. So as I mentioned before, our university is really young. So the university is founded in the 1966. So this year is turning to the 52 years old, okay? So it's pretty young, but however, we have 15 of the faculties, and right now we have the 30,000 of the students, including 6,000 of graduate students from different countries around the world. So myself is in the Civil Engineering Department of the Civil and the Schulich School of Engineering. So in the Schulich School of Engineering, we have others 4 departments, the Chemical and Petroleum Engineering, and the Electrical and Computer Engineering, Geomatical Engineering, and the Mechanical and Manufacturing Engineering as well. So in the Civil Engineering program, so we offer the graduate study opportunity in the following of the 11 of the different fields. Myself is in the water resources engineering. So let's talk about my research. So I did conduct research more than 10 years. So my research interests mainly in the urban stormwater management, use a low impact development technology, LIDs. And I'm also interested in to investigate the impact of the climate change on water resources, hydrological frequency analysis, and also I'm interested in the surface water quality assessment and management. And also I got the opportunity to touch my hand on the freshwater ecology, especially looking at the impact of the aquatic plants on the dissolved oxygen in the riverine environment. And in the last 10 years, I also try to explore the use of advanced computing techniques in the hydrological and water resources modeling. Today, I only have the 40 minutes to share my research with you, so I cannot cover all this project in all this area. So I would like to share my research story highlighted in the 3 different fields. So let's look at urban stormwater management first, okay? So everybody knows the urbanization affects the hydrological response of the watershed. So if you look at the hydrograph at the bottom corner over there, so what you can see is the blue line, that is the hydrograph before the urbanization of the before development. And the red dot line, so that is a hydrograph, the after urbanization or the after development. So the big change you can see because of the urbanization, so we can observe significant increase of the peak flow, and we also can observe the decrease of time to peak. So we clearly see the urbanization affects the hydrological response. So, but let's see the photos. What does the photo mean? So as you can see, so the urbanization also caused some of the problem in the water quality in the water receiving bodies. For example, the rivers and also the stormwater ponds and the lakes and so on. Because if you pay your attention on the photo on the bottom, so that's a photo we taken and from a stormwater pond during the summertime. So what you can see from that photo, so you can see the significant growth of significant amount of the growth of the aquatic plants. So what this can cause any of the problem? So because the growth of the aquatic plant can significantly reduce the dissolved oxygen in the stormwater pond, then affect aquatic animals, and will make the stormwater smelly. So that's not a good thing. So from here, so we can clearly see the urbanization can cause some problem in stormwater quantity and also cause some problem in the stormwater quality as well. So let's look at the management concept we apply in order to manage stormwater in the city of Calgary. So traditionally, so we take the simple idea. We are going to use the stormwater drainage system and the stormwater pond to quickly collect the surface stormwater runoff and then discharge into the stormwater pond. That's a traditional concept we use to manage stormwater. But however, later on, we realized some problem in this kind of the management concept. So one of the problem is from the infrastructure we use. For example, we use underground stormwater drainage system. So the maintenance and the replacement of this system is quite costly. So look at the stormwater pond in the management system. In the Calgary, we have hundreds of the stormwater pond. So the problem we have right now, because we know the sediments from the catchment gradually accumulated at the bottom of the stormwater pond. So because of this, we'll gradually reduce the storage of the stormwater pond. In a certain of the time period, we need to get rid of the sediments at the bottom of the pond. But the problem is, in the city of Calgary, we have hundreds of the stormwater ponds. Even though we're doing this in one pond, that is very, very expensive. So another problem we have here is because water quality is another issue we would like to pay attention. So from many of the research has been conducted in this area, demonstrated that the stormwater drainage system is not very effective to remove some of the pollutants, such as nutrients and any other of the dissolvable pollutant. So because we realize this kind of the problem in the traditional management strategy, so here the city of Calgary has the intention to include using the low impact development technology, LID, to manage stormwater. So what's the advantage of the low impact development LIDs? So the one of the advantages is very clear. So we can see this kind of the technology is environmental friendly, and also many of the research has been demonstrated that this kind of the technology is efficient in terms of the managing stormwater quantity and also the stormwater quality as well. So if we implement the LID system in our stormwater management system, so we can reduce the footprint of the stormwater pond in the watershed. So right now, so I'm looking at the three different kinds of the LIDs. One is a permeable payment. What's the difference between the permeable payment and also the normal payment? From the name, we know that permeable payment allow more water infiltrated through the payment. So the second type is a bioretention. So the bioretention is a technology using the combination of the vegetation and the soil media to enhance the water quantity and to reduce the water quantity and enhance the water quality at the same time. So the third type would be the green roof. So green roof, again, so from the name, you can see the green roof is a roof covered partially or completely by the combination of the soil and vegetation. So as I mentioned a couple minutes ago, the LID is now new, okay, is now new. Many of the research has been conducted in many of the municipalities around the world, especially in the US and some of the European countries as well. So the question would be, so why I still interested in to do the research on LIDs? So here, that's my answer to this question. So as I mentioned, many of the research on the LIDs have been conducted in some of the municipalities in the US and many of the countries in the European countries, right? So this place quite often has a mild climatic condition. So let's look at climatic condition in Calgary. We have really, really enjoyable summer. It's not that hot, it's not that humidity, but we have really, really cold and long winter season. So we have the question, so if the LIDs, if we implement in the city of Calgary, that they are okay for the specific climate condition for the city of Calgary. So the next question would be the vegetation. So for example, when we use a green roof and bioretention, the vegetation is a very important component of this technology. So because we know the vegetation play a very important role, but however, if we use LIDs in Calgary, we are going to use a different type of the vegetation. So we would like to answer the question, in our specific climatic condition, our native vegetation, how they perform in this LIDs? That's the second question. So the third question would be the material we are going to use to construct the LID. So for the construction, of course, we prefer using the material locally available, right? So for this, of course, the material available for us would be different from the material available any other place around this world. So our question would be, what's the role of the material for the LIDs? So to answer all this question, so of course we need to do the further research on the LID, even though it's not the new technology in the stormwater management. So when we do the research for the LID, so quite often we would like to evaluate the performance of a LID from the two different aspects. One is the hydrological performance of a LID. Another one would be the water quality performance of LIDs. So when we evaluate the LID from the hydrological performance perspective, quite often we pay more attention on several of the hydrological variables. For example, the peak flow reduction, the time to the peak, and the discharge time, and the water retention, and so on. When we evaluate the water quality performance of the LID, so quite often we are paying attention on the pollutant removal efficiency. In other words, we interested in how much pollutant can be removed by the LIDs. So here, so in all my research on the LIDs, so we are trying to understand the performance of the LIDs. So let's look at the first type of the LID, so that would be the permeable pavement. So in this research, we use the field scale and the laboratory scale of the permeable pavement to evaluate the performance of the permeable pavement in the specific Calgary climatic condition. So in the field, so as you can see from the middle top of the graph, that is the field scale of the permeable pavement. So we use a simulated 100-year storm event and then evaluate the performance. So in the simulated event, we collect the stormwater from the stormwater pond nearby and mix the stormwater with the sediments we collect from the street and then apply onto the surface of the cell. And if you look at the photo on the, I think it's the left-hand side top corner there, so we have the stormwater manhole is nearby. So the outflow from the permeable pavement will flow further to the downstream through the stormwater manhole. So from here, we monitoring the water quantity and grab the sample from the water to do the chemical analysis. We can evaluate the performance of the permeable pavement. So for some of the questions, it's really hard to be answered through the field observation. For example, if we're interested in the impact of the thickness of the gravel layer of the permeable pavement. So we need to change the thickness of the gravel layer. Once the field scale of the LID is constructed, so it's really hard to change the thickness of the gravel layer. So in order to answer this kind of the question, we are going to use a laboratory experiment. So if you pay attention on the 3 photos at the bottom, so that shows the setup of our laboratory experiment. So because this project already finished, so I have some of the preliminary results I can share with you today. So if you look at the graph here, so the graph shows the removal rate for the TSS, that's total suspended solids, and the TP, that's the total phosphorus, and TN, that would be the total nitrogen for each type of the permeable pavement. So in this project, we look at the 3 different types of permeable pavement. PA, that's a porous asphalt. PC, that is a porous concrete. The PICP, that's interlocal paver. So look at the graph. So the TSS in red, and the TP in green, and the TN in the blue. So here, we are interested to know if the permeable pavement perform differently in the winter season and the non-winter season. So from the result, we can see we didn't detect the significant difference in terms of water quality performance for all of the 3 different types of the permeable pavement. But however, for the TN, we observed the large variation. So later on, we found out the large variation because we have the large variation in the temperature of the permeable pavement. So here, one interesting thing we observe from the field would be the hydrological performance of the permeable pavement. So the hydrological performance of the permeable pavement is not stationary. So in this research, we try to figure out what kind of the factors result into the non-stationary performance of the hydrological performance. So in order to answer this kind of the question, we investigate many of the hydrological variables, and then we found out the variation of the hydrological performance, such as the peak reduction and the time to peak and the discharge time, all related to the surface infiltration rate of the permeable pavement, as you can see from all the plots, all the 3 plots for the different type of the permeable pavement. So this graph actually shows the time series of the surface infiltration rate of the 3 different types of the permeable pavement. As you can see from the graph, so you can see the surface infiltration rate generally decreases along with the time. And in the 2013, so we applied the pressure washer to try to recover the surface infiltration rate. So we successfully recovered surface infiltration rate. But later on, we still observe the gradually decrease of the surface infiltration rate. So what does this observation tell us? So this observation tells us so we can use the surface infiltration rate to model the variation of the hydrological performance of the permeable pavements. So later on, my student constructed the model. The model successfully captures the temporal variation of the hydrological performance of the permeable pavement, use the surface infiltration rate as input variables. So in the lab, so as shown in the 3 plots, so you can clearly see, so the TSS removal rate and the TP removal rate is very sensitive to the size of the gravel layer and also sensitive to the thickness of the gravel layer we used. But however, if you look at the plot at the bottom there, so the TN removal rate is not very sensitive to the size of the gravel and also the thickness of the gravel layer because we only observe small variation in when we use the different size of the gravel and the different thickness of the gravel layer. So what does this result tell us? So for the engineer, if you are going to design the permeable pavement, of course, if you set up any of the management target, so we can use this kind of the result to help us to select what type of the gravel we should use and what specific thickness we should use in order to reach specific management target. So my research about the second type of the LID is a green roof. So in this research, we have the field scale of the green roof, which is located on the top of the municipal building of the city of Calgary, and nearby, in order to compare the performance of the green roof, we also have the conventional green roof for the comparison purposes. So in this research, we also conduct the laboratory experiment as well to answer some of the questions we cannot answer from the observation from the field. So in this laboratory experiment, we look at the 3 different types of the growing media. 2 of them are from the city of Calgary, locally available, and 1 is from the province of the British Columbia in Canada. So in this research, we look at the 3 different types of the growing media, and we also look at the growing media at the different thickness, 100 millimeter, 150 millimeter, and 200 millimeter. And we also look at the 3 different, the magnitude of the storm event, 2 years, 5 years, and 10 years storm event. So we are going to use a simulated storm event to evaluate the performance of the green roof cells. So here's some of the results about the hydrological performance. So the project here, we really interested in to know what kind of the factors largely affect the hydrological performance and the water quality performance of the green roofs. So here is some of the results about the hydrological performance. So as you can see, the plot summarizes the result and show the relationship between the antecedent soil moisture with some of the hydrological performance metrics. For example, the reduction rate and the lag time. As you can see here, doesn't matter which type of the soil. We can see there is a significant dependence between the antecedent soil moisture and the hydrological performance of the green roof cells. So in generally, we see that the hydrological performance and decreases along with the increase of the antecedent soil moisture. So then from here, another things we observed from this study, about the chemical leaching. So chemical leaching is not uncommon for the green roof and the bioretention, especially at their initial operation stage. So in the field, we observed in the laboratory, we observed the nutrient leaching from the green roof cells. So as you can see from this plot, that shows the box plot for the concentration of the nutrients from the outflow from the green roof cells. You can observe the significant difference among the 3 different types of the soils. So what this result tell us, this kind of result tell us, the nutrient leaching is very sensitive to type of the soil we are using to construct the green roof. So if the nutrient leaching is a problem, we know the leaching is a problem. So we would like to construct a model that can help us to understand the leaching process and quantify the amount of the pollutant leaching from the green roof. So in order to do this, we use the data available, and to do the statistical analysis, we would like to identify what kind of the factors significantly affect the nutrient leaching from the green roof. So as you can see, all the plot shows the relationship between the different species of the nutrient and the cumulative inflow. So what is the cumulative inflow? The cumulative inflow, that's the amount of the water from the first of the simulated event to current event. As you can see from this graph, in general, the concentration of the nutrient species decreases along with the increase of the cumulative inflow. So that's the same result we can see from the orthophosphate and the TP as well. So what does the result tell us? So the result tells us maybe we can use the wash-off process to simulate the nutrient leaching from the green roof cells. Okay, so everybody know that the pollutant accumulation and wash-off has been commonly used to simulate the stormwater runoff quality. But here, we would like to develop a model that based on the wash-off process to see if we can capture the nutrient leaching very well for the green roof. So this is an ongoing research project. I have one PhD student is trying to develop such kind of the model right now. So hopefully in the near future, I have more interesting results to share with you. So here is some of the results from the field scale of the green roof. So we summarize the result, use a box plot for the different seasons from winter, spring, summer, and fall. What we can see from this plot, the concentration of the different species of the nutrient is relatively higher in the spring, and the concentration is relatively lower in the summer and the fall. What does this tell us? They tell us the water quality performance of the green roof varies among the different seasons. So we can send the message to the engineer. So when you design the green roof, we need to pay attention about the seasonal variation of the water quality performance of the green roofs. So the third type of the LID is the bioretention. As you can see, the bioretention, we have the 2 or 3 major components. First one would be the vegetation. Second one would be the growing medium, that's the soil. Some of the bioretention with the drainage layer, that's a gravel layer. Some of the bioretention do not have the drainage layer. The infiltrated water will recharge into the groundwater directly. That's the structure of the bioretention. So from the previous research conducted by one of my colleagues on the bioretention in the city of Calgary, looking at his result, we observe very interesting, but it's not surprising, the phenomena, the hydrological and water quality performance of the bioretention is not stationary. As you can see from the scatter plot on the right-hand side of the screen. So you can observe the hydrological performance degrade along with the time. However, we observe a slightly improvement in the TSS removal rate. So we have the question. We know the hydrological and water quality performance of the bioretention is not stationary. So what kind of the factor we need to look into to understand the temporal variation of the performance of the bioretention? That's the question we have. So the bioretention project is an ongoing research project. It started from the 2017. So through the literature review, we also identify several of the interesting research topics as well. So the first one, through the review of the literature, we find out if a researcher is interested in the role of the soil of the bioretention, quite often the plant the same vegetation onto the different type of the soil, then evaluate the role of the soil. So if a researcher is interested in the vegetation, they are going to plant different species of the vegetation onto the same type of the soil, then look at the performance of the soil. So we know that for the bioretention, that is a combination of the vegetation and the soil. We cannot separate the vegetation from the soil. We cannot separate the soil from the vegetation either. So here, the question we have, what are the roles of the soil and the vegetation when we take the interaction of the soil and vegetation into consideration? That's our first question. So the second question about the role evapotranspiration in the hydrological performance of the bioretention. So in many of the previous studies on the LID has been conducted in the mild climatic condition. But for the city of Calgary, we have the totally different climate. So we have the semi-arid climate. So that means the potential evaporation is higher than the total precipitation we receive in the city of Calgary. And also the time interval between the two storm events can be longer compared to other locations. And also we have the many of the small storm events as well. So looking at this, we expect the role of the evapotranspiration in the hydrological performance of the bioretention should be significant in our place compared to any other place where has a mild climatic condition. So in this research, we try to answer the question, the role of the evapotranspiration in the hydrological performance of the bioretention. So the third question we have, we know the vegetation plays a very important role here. So, and of course, for the bioretention, the media clogging is a big problem we are facing, okay? So from our preliminary observation in the Alberta, so we found out the vegetation can help enhance infiltration rate of the bioretention. What does this mean? So this means the vegetation may help in delay or even though preventing the media clogging. So we would like to confirm this through our research project. If it's right, then to what kind of the degree the vegetation can help in delay or preventing the median clogging? That's our third question. So the last question, I already discussed this question a minute ago, is about the temporary variation of the hydrological and water quality performance of the bioretention. So to answer all this question, we need a research facility to do this. So fortunately, we have wonderful research facility to conduct this kind of research to answer the question we have. So our research facility located in the town of the Okotoks. So that is located further south of the city of Calgary. So in this research facility, we have the 24 testing bed that is 2 meter by 2 meter in the surface size. And we also have 3,800 square meter full scale of the bioretention in the facility as well. So here is a photo of the 24 of the testing beds. So here is the layout of the 24 testing beds. As you can see in this research, we use 3 different types of the growing medium. So 2 of them, 70 and 40, that is from the design guideline for the city of Calgary. The last one, the CL, that is a clay loam. So this kind of the soil is available locally in the Calgary, okay? So in this research, so for each type of the soil, we have 8 testing cells. 2 of the testing cells planted with woody species, and other 4 planted with a mixture of the herbaceous. And another 2 we plant with the tough grass used as a control for each type of the soil. So we plant the vegetation in the last June. So this is the vegetation looks like in the July, and in the August, and in the September. So we would like to see the vegetation was doing the good job in the last year. The good news, the vegetation is still survives through the last cold winter in the Calgary, still doing well. So we can start our field work in this coming May. If they die, we have to replant them again, okay? So for this bioretention, as I mentioned, because we just started the project in the 2017, I do not have very interesting results to share with you today, but hopefully in the future, near future, I have more interesting results to share. So my research on the hydrological modeling. So I do not know how many of you heard about the 2013 Southern Alberta floods. No people, okay. So we had really a huge flood event in the 2013. So normally the maximum peak flow on the Bow River is around the 300 cubic meter per second. In the 2013, the maximum peak flow would be the 1,700 cubic meter per second, almost, I think, 6 times higher than the normal. And another thing I would like to mention here is 2005, the city of Calgary had another flood event in the 2005 as well. So if you go through the literature, so if the researchers are doing the climate change impact on the water resources, so many of the researchers would like to see, okay? So under the climate change scenario, okay, so the intensity of the rainfall becomes more intensive, and the frequency of the extreme event becomes more frequently, okay? So it sounds like this is true for the city of Calgary because we had a flood event in the 2005. We have another flood event, the big flood event in 2013 again. It sounds like it's true for our city. So our city have some of the problem or challenge to face to manage the water resources for the future, because we need to think about if the climate change affects the water resources we have in our province or in our city or not. Okay, so to help answer this kind of the question, so my research topics in this area include the 3 different research areas. So first one would be the hydrological frequency analysis and the changing climate. So we know under changing climate, many of the hydrological variables would be non-stationary. So if our data, hydrological variable, is non-stationary, so how we do the frequency analysis? Because we know conventionally, so the frequency analysis needs the data be stationary. So the second one, so when we study the climate change impact, we cannot measure any of the hydrological variable in the future. So how we do this? We have to study the climate change impact through the modeling. So we have the 2 different types of the model. We have the physically based hydrological model. We have the data-driven hydrological model. So physically based hydrological modeling can help us to understand the physical process better. But there is one problem. In order to develop the physically based hydrological model, we need intensive data, and we need our better understanding of the hydrological process. But however, we know we are not perfectly understand all the hydrological process yet. So here, we propose to using the data-driven modeling approach. The data-driven modeling approach is easy to develop if you have the inflow and the outflow, then you can develop the model. Even though there is a criticize from the research community for the data-driven model, because they say this kind of model cannot help us to further understand the physical process. But many of the research, including research from myself, we prove that the data-driven modeling approach is efficient in terms of modeling of some of the hydrological variables. So the third kind of the research topic I have would be the uncertainty. If you are going to study the climate change impact, the topic of uncertainty cannot be bypassed. What do I mean here? So if you look at the future climate projection from the general circulation model, CUCEI model, so different model give you the different projection for the future climate. What does that mean? That means there is a huge uncertainty in the projected future climate scenario. If you would like to use the future projection for the climate scenario for your study to look at the climate change impact, of course, we need to think about the uncertainty from the projected future climate scenario in our study. So the next, I would like to discuss more about the hydrological variables, the data set. So as you see here, I would like to ask you pay more attention on the red, the color of the red. So this graph shows the annual peak flow measured at the Calgary on the Bow River. So as you can see from here, the dashed line shows there is a significant decreasing trend in the data set. If you pay more attention in the time window from the 1917 to today, so you can see there's a slightly upward increasing trend. So from here, we know the data set is not stationary, and we also observe the change point in the data set as well. So another data set, that is annual maximum daily rainfall we measured from the 2 rain gauge stations in the city of Calgary. From here, we can clearly see there is an upward trend in the data set. So the third of the data set is collected from one of the rain gauge stations located in the city of the Guadalajara. Okay, as you can see here, so the annual maximum daily rainfall data set, we did not observe the significant, the upward or the downward trend. But however, if when we calculate any other statistic characteristics, for example, we calculate the variance or the skewness or kurtosis of the data set, we observe a significant upward or downward trend from this data set as well. So what does this tell us? So this kind of the information tell us, in generally, the hydrological variable data set are not stationary. Okay, if it's not stationary, so the question is, how we do the hydrological frequency analysis if the data set is not stationary? That's the question we have. So to answer this question, so we propose to use uncertainty to quantify the impact of the non-stationarity of the data set in the frequency analysis. To quantify the uncertainty, we propose using the ensemble modeling approach. So as you can see, the two plots here, that's the result come out from the research. So the scenario number 1, so that is a frequency curve. We developed it without including the 2013 the peak flow. So scenario number 2, that's a result from the data set including the 2013 the peak flow. What's the difference between these two? So when we use deterministic modeling approach, we can easily to evaluate the performance of the model by comparing the model output and your field observation, right? So you can see if your model performance okay or not. But however, for the uncertainty, we do not have the real measurement. We do not have the real measurement. So the question would be, how you evaluate your model? That's our question. So as you can see from the two plots, so one with the 2014 very high flood event, another one without the 2013 flood event. What's the difference? If you pay attention on the shaded area of these two graphs, so you can see the uncertainty level for the scenario number 2, including 2013 flood event, is quite wider compared to the uncertainty level from the scenario number 1 without including the 2014 flood event. What does this tell us? So this tells us if we include the 2013 flood event, introduce the high degree of the non-stationarity into the data set. So the result tells us if the degree of the uncertainty in the data set is higher, so the uncertainty level would be higher. That makes sense to everybody. So from here, so we can see, we prove this approach is efficient. But however, we have some problem when we use this approach to quantify the uncertainty. We need to make some subjective criteria to optimize the range of the uncertainty. So in order to overcome this shortcoming of this disadvantage of the ensemble modeling approach, we propose to use particle filtering techniques. So in this technique, we do not need to make any of the subjective criteria, okay? So this technique helps us to quantify uncertainty from the data itself. So this is ongoing research. Hopefully in the summer, we have the solid result out from this research. So in terms of hydrological modeling, so myself, and intensively use artificial neural network, ANN. I do not know how many of you know the ANN. Please raise your hand. Okay, it's totally new. Okay, so let me give you a short introduction about the ANN, artificial neural network. As you can see on the top, that is the structure of the ANN. So we have the 3 layers: input layer, hidden layer, and output layer. So the advantage of the neural network that is we can easily to change the structure of the model by increasing or decreasing the number of the neurons. You can easily to change the model structure. So even though the model is very simple, but many of the research and also research conducted by myself prove this is an efficient way to model some of the hydrological variable. So I use the ANN for the hydrological frequency analysis. I use the ANN to model the stormwater runoff quantity and the quality, and I also use the ANN to model the dissolved oxygen in the riverine environment as well. So here, even though we show that ANN is an efficient way to model some of the hydrological variables, such as the flow, but here we find out some of the problem with ANN. So as you can see, the plot on the left-hand side, so that is when we use the ANN to forecast the flow. So forecast the flow. So the blue line, that's observation. The red dot, that's modeling result. The shaded area, that is a prediction interval. From that graph, you can clearly see the the result from the AAN are not acceptable because you can see from the peak, there's around the 7 days of the time lag. Of course, the forecasting is not acceptable at all. But however, if you pay attention on the right-hand side of that plot, we use a WAN. What is a WAN? The WAN is a wavelet-based neural network. So what is the difference between the AAN and the WAN? So the AAN, we use the measured flow and the rainfall as the input into the neural network. So WAN, we use a wavelet transferred the measurement as the input to the neural network. Because through the data transformation, we can extract more information from the data itself, and then we can further enhance the model performance. So as you can see on the right-hand side of that plot, so basically we would like to see this kind of the model can produce acceptable forecasting for the flow at the Calgary. So as a future research, so we know there is another type of the neural network, is called the deep learning neural networks, the DNN. So myself, I'm really interested in how we apply this DNN into the hydrological modeling. That's my future research area. So at the end of my research presentation, I know I used most of my time, all right? Okay, so at the end of my presentation, I would like to acknowledge my contribution from my colleagues. So Dr. Katerina Vallejo from University of the Victoria, and Dr. Angus Chu from the University of Calgary, and Dr. Asman Khan from the York University in Canada, and Dr. Kasavisuwanasan from the Indian Institute of the Technology. And also, I would like to thank you the contribution from all my graduate students and the funding from the financial support from the government, federal government of Canada, and the industry partner as well. Okay, so that's all my presentation. So if you have any questions, so I think I still have a little bit of time to answer several of the short questions. If you have the long question, so I think we can discuss after my presentation. Okay, thank you very much. So if you have questions, please raise your hand. Okay, go ahead.
Thank you. First, Doctor, this presentation is very, very interesting to me. I think the Canadian research about water are the best. The fact I use the Water Quality Index of Canadian Council because I think it's the best of the world. Oh, so I say my question in Spanish to. Bueno, referente a la presentación, creo que la implementación de este tipo de tecnologías son imprescindibles dados el cambio climático y la escasez de agua que está viviendo el mundo. La situación de Calgary tiene sus particularidades a diferencia de una ciudad de Guadalajara. Siempre he admirado la manera en que hacen la cuantificación de contaminantes, saben los canadienses cuánto entra, cuánto sale de agua y podríamos decir que tienen un conteo general de con cuánta agua cuentan y pueden disponer en el presente y en el futuro. En el caso de la ciudad de Guadalajara, pues bueno, hay la particularidad de que agua limpia se mezcla con agua sucia y luego se mete toda a tratar. Vi la gráfica que presentó Cuauhtémoc Vidrio, estaba hasta el 2008, 2010, no recuerdo, con lo del cambio climático. Ahorita es un verdadero electrocardiograma, ya no se entiende nada, o no llueve o llueve muy feo. Y la zona sur se inunda bastante y sucede otra vez la mezcla de aguas limpias del lago de Chapala, que es nuestra principal fuente de abastecimiento, y de agua que también viene de Chapala, pero de manera superficial. y se contamina con vertidos legales e ilegales de aguas negras. Así que tener un balance de masas o balance de agua resulta un poco complicado. Sin embargo, dado que CUCEI es quien organiza este evento, es posible implementar este tipo de tecnologías a bajo costo para, en lugar de utilizar esa agua que cae para recarga de acuíferos, para que sea recirculada en el mismo centro y utilizada para riego?
That's really good question. So, good question. So for myself, I also, even though I didn't include this in my presentation today, the city of Calgary actually looking at the reuse of the stormwater in stormwater pond for irrigating the public land. But before we implement this kind of the things to reduce the consumption of the potable water, so there's a couple of things we need to verify because there's some of the concern in terms of public health. So the one thing we did in the last several years looking at the microbiological quality of the stormwater. So for the low impact development I discussed today, so they're reported to have certain of the way to remove some of the microbe contamination as well. So if they satisfy the requirement for the public irrigation, so you can reuse the stormwater. But as you mentioned, so there is a special variation, right? Some place there's a flood event, some place doesn't, and some place with surface runoff quality is really bad, some place is much better. So because of variation, of course, we need to conduct some special analysis to look at how the watershed or the city looks like. So maybe you can identify the hot spot in terms of water quality management. So that is a spot because quite often we observe the high concentration of the water pollutant. Maybe that's a place you need to pay more attention. So here, so you also mentioned the climate change. Okay, so how the climate change affect this kind of things? So the only things we can answer is if we can see some of the relationship or the dependence of the performance of this kind of technology on the climate. If you understand how the climate change in the future, you can kind of project their performance in the future. But again, as I mentioned in the presentation, the climate change can be affect the different place in the different way. Some places become drier, some places become wetter, some places got more flood event, other places got less flood event. So how we do this to understand climate change? So we need to look at the historical data to help us to understand the dependency of the hydrology and with the climate. And then looking at the future climate scenario, what's the future climate scenario would we look like? And then give us some of the big picture. So if we have this kind of the future climate scenario, what kind of the things would happen in the future we can predict. So for example, if you think the water quality of this pollutant increases along with the increase of the precipitation, if in your future climate scenario you see the increase of the future precipitation, you can have some quantitative picture. So that means in the future, the concentration of this pollutant would be further increased, can give us this kind of the qualitative picture. But in terms of quantitative analysis is really challenged to my understanding, because as I mentioned in the presentation, we have the huge uncertainty in the future projected climate scenario. For example, for the precipitation, one GCM model tells you in the city of the Guadalajara is a fake example, okay? So in the city of the Guadalajara, in the next 50 years, the precipitation increased 5%. Another GCM model will tell you in the city of the Guadalajara only increase 3%. Maybe another GCM model will tell you in the future of the 50 years, the precipitation in the Guadalajara decreased by 2%. Which one you are going to believe? So you don't know which one is right, which one is wrong, because that is a future projection, right? Then for this, you need to take the uncertainty. So of course, just like the weather forecasting, tomorrow is going to rain is at 60% of the chance. That's the same thing. So if you look at the uncertainty, can give us some of the picture about, in the future, so this would be happen at a certain of the possibility. This would be happen at a certain of the possibility. So of course, always prepare for the future, manage water resources for the future is really challenging because it always come up as a possibility. 70% of the chance is acceptable, or 50% of the chance is acceptable, or higher, 90% possibility is acceptable. That's kind of the really challenging question. I do not know if I answer all your questions or not. Thank you.
Aún hay espacio para más preguntas. Si nos pueden auxiliar, por favor.
Hi, thank you for the conference. I have a question. I live in Mexico City, and there is a special thing with the soil. The soil is very mobile, so how this can affect if we apply this model on that kind of cities? Because have you considered the kind of soils?
Okay, so you mean the soil we use for the LID is easily mobilized? Is that your question, right? Okay, so when we implement the LIDs, so of course many of them would be the combination of the vegetation of the soil. So the first thing, the vegetation can help us to hold the soil to a specific place. And also, when we construct the LID, of course, we are not going to build the LID on the top of the surface. Quite often, the surface of LID would be aligned with the land surface. So that's the second thing we can prove and prevent the mobilization of the soil. Okay, so of course, there's some of the erosion occur on the surface of the LIDs. There is an erosion on the surface. So in terms of the LID, quite often, in couple of years time interval, you need to, sometime maybe you would like to add more soil to your LIDs because some of the erode away by the surface flow or by the wind and so on. So we need to do something like that. And however, so in some of the case, because we do not observe significant change in the thickness of the bioretention or the green roof. Because why? Because especially for the bioretention, receive the sediments as well. So the sediments accumulated on the surface layer of the bioretention, sometimes we may observe the increase of the thickness of the soil. So from this kind of things, of course, we can avoid the erosion of the soil. So we can make sure the bioretention has a certain of the required thickness. So that's your question? Okay, thank you.
Ok, bueno, tenemos tiempo para una pregunta más. Si la hay en la audiencia, puede preguntar.
Hello, I was wondering, you mentioned you were using wavelet transforms for the neural networks.
Okay.
So I was wondering if you have any insights on how to select which kind of parameters for the wavelet to apply to your signals.
Okay, so you mean the neural network, what kind of a signal we input?
No, what kind of parameters to use for the wavelet transform?
Oh, the wavelet transform. Okay, so you mean the wavelet transform?
Yeah, but I mean, there are different parameters you can apply to the signals you are using. So I don't know, for example, instead of using the DBO to the hat or the Mexican hat, maybe, also the level of transformations you do.
Yes, okay, so one thing would be you rate, we would like to select the level of the transformation, okay? So to my understanding, so there is a different wavelet function you can select. So how we select among the different function you would like to use when you do the wavelet transformation. So basically, I would like to see the approach, we use a try and error approach. So you try one, to look at, so just like you run the preliminary experiment, you try use this one to see what's your modeling output look like. You try another one to see the modeling output looks like. And then from the try and error approach, you can select what kind of the function is applicable for your data set. From my own experience, I think for the different data set, you might use a different transform function. And also another variables we decide would be the level of the transformation. So you are going to transfer the two level of the transformation of the 4 and the 6. Again, there is no any of the schematic approach you can follow. Again, for the different research, they always use their different way. So again, my suggestion is you are going to use the experimental run to try use a different level and look at the preliminary result, then can use the result to help you to decide what kind of the level you would like to transfer your data. So there is a disadvantage to develop the data-driven model. So quite often, so if given you the same data set, the model you developed it can be different from model I developed it. Because the data-driven model, quite often they have a really, really flexible structure, right? Just like the neural network. You can increase the number or decrease the number of the neurons to change the structure. So quite often, there's no one unique final solution. Your model can be different from mine because I can use the different statistics, the metrics to help me to optimize the model structure. I use a matrix number 2, you use a matrix number 1 to evaluate the performance of the model, right? Of course, at the outcome of the modeling would be different as well. But no matter what kind of the data-driven model you are going to develop, you need to calibrate your model, you need to validate your model. If the model performs good in both the model calibration and the validation, then you have confidence my model is acceptable. I don't know if I answer your question or not. Thank you.
Okay. Muchas gracias, le decimos a nuestra magistral expositora para dar pie a la entrega del galardón Jorge Matute Remus, de manos del presidente del Ifses 2018, Ernesto Cervantes, en nombre del comité organizador y de la Universidad de Guadalajara, por supuesto, recibe la doctora Hyun Jennifer Hee. Ahí queda el momento de la entrega-recepción. Bien, solo nos resta agradecer con ello la presencia de todos ustedes y despedimos este día. Les deseamos una excelente tarde. Muchas gracias.